Okay, so the next type of problem we're going to run into is a sampling distribution of a mean. And this is when they give you the mean and they give you a sample. They'll say we sampled this many, and we're going to compare the two and see how far away from the sample mean is from the actual population mean. There are conditions involved. It has to be independent. So the members of the sample must be independent and random. There's a 10% rule. The sample size must be no more than 10% of the population. And then the nearly normal rule. For all intents and purposes, you should know that n needs to be bigger than 30, or it needs to tell you that it follows a normal distribution. And here's the things that you'll get in the problem. You'll have the mu, the actual population mean. That's the actual mean. You have the sigma, the population standard deviation. You'll have the sample size, n. They have to tell you how many they sampled for it to be one of these problems. And the sample mean, some sort of comparison. Like, it'll ask, what is the probability that that sample has a mean of this or less or this or more? That's your comparison mean right there. And here's your formulas. The mean you're going to use in Stapplet is just mu. The standard deviation of the sample is going to be the population standard deviation divided by the square root of n, which is the sample size. So as that sample gets bigger, this n value, as the n gets bigger, the standard deviation is going to get smaller, right? It's going to get more accurate. It means that the data is going to be less spread out. It's going to be more accurate. And then here's your z-score formula. It's your comparison mean, the one we're comparing, minus the actual mean, the population mean, divided by the standard deviation. So let's take a look at an example problem. The average salary of a small fashion designer in Texas is $46,700. So that is our mu right there. That's the actual average salary. And a random sample of 42 fashion designers, that is our n. The sample size, we're sampling 42 people, are drawn from the city of Houston of Austin. The standard deviation is 5,600. That is our sigma. And the probability that the mean of the salary is more than 44,000. What's the probability that it's more than 44,000? So that is our x bar, our sample mean. That's our comparison. So the mean that we're going to use in Stapplet is just equal to 46,700 because it's equal to just the normal mean. The standard deviation we're going to use is going to be the standard deviation 5,600 divided by the square root of n, which is 42. 42. Whoops. The square root of 42. All right, so I'm going to go to desmos.com/scientific, and this is what it looks like right here. This is a really good calculator to use for this test. So I'm going to put in 5,600 over the square root of 42. So get the Desmos calculator if you need to. 5,600 divided by the square root of 42. So, oops. Gotta be careful. Go back down there. Square root of 42. Now we got it in there correctly. And we get 864.0987. We're going to call that 864.099. We'll go 3 digits on that. Go at least 3. I'd probably go 4. Let's do 0988. Yeah. 864.0988. So we have our mean and we have our standard deviation. And what we're comparing it to is we're looking for the probability that x bar is bigger than 44,000. So I'm going to put to the right of 44,000. So I'm going to go to Staplet, and I'm going to pick normal distribution. And the mean is 46,700. 46,700. And the standard deviation right there is 864.0988. 864.0988. And I'm going to plot, and you're going to pick to the right of, and you're going to compare it to 44,000. To the right of 40, because it's more than, what's the chance that it's more than 44,000? And 44,000 is below average. It's well below average. So this should be, most salaries should be above 44,000, right? So to the right of 44,000 should be the vast majority of them, and it is. A 99.91% chance you would have a salary over 44,000, which makes sense because 42 people, if you average 46,700, 42 of them shouldn't be that low. So you get 0.9991 as your answer, which means there's a 99.91% chance that you would have a salary higher than 44,000 from that group of people. All right, that is the sampling distribution of a mean.